Hello and welcome back. We have been so far making LEDs blink in various ways. We got 2 LEDs blinking, so exciting. We got 1 LED blinking, oh my gosh. But in none of these cases, all these LEDs blinking and all this stuff, it's all about just a pre-programmed behavior that just proceeds as programmed. It reads no information from the world. It doesn't respond to the world in any meaningful way. We want to learn how the Arduino can actually know something about the world. Which brings us to the subject we're going to learn next is the very first input we're going to learn. The input is called a potentiometer. We will often call these a pot for short. So imagine, if you will, we're just returning to the hydraulic metaphor. Imagine a tank of water. Water, water, water. Here's a pipe. End of the pipe goes into some drain where the water just kind of rushes out and goes into a grate. There's water all along the pipe. Now imagine we have a little pressure gauge. I've got a little pressure gauge here. Got a little pressure gauge here in the middle. And a little pressure gauge here right at the end. The question is, do you think the pressure will be the same at all 3 locations along the pipe? And on the one hand, you might think, well, it's all the same pipe, so yeah, probably. Actually, the flow is going to be the same. So if there's 1 gallon per second going past here, there's also going to be 1 gallon per second going past here. That's going to be steady for the entire pipe. But the pressure actually doesn't have to be the same. The pressure that's here is going to be really close to the pressure in the tank. The pressure that's over here, that's after the water has flowed through the pipe for quite a distance, it actually isn't necessarily going to be so high at all. In fact, it'll be probably kind of a low pressure. And the pressure in the middle, that will be kind of a middle pressure. So the pressure will fall along the path of the flow. Now let us imagine I'm drawing a very long resistor. And if I put it this side of the resistor, a 5-volt power supply, and I put it this side of the resistor, ground, which means 0 volts. Well, a resistor is like a pipe. There's a flow going through it. Will the amount of flow going through here be the same as the amount going through here? Yes. But will the pressure vary? Will the voltage vary? So pressure in square quotes, but voltage is what we're going to be talking about. Yes, it can. So if we were to measure the voltage at this point in the resistor, right here, we would measure 5 volts. What if we were to measure the voltage at this point in the resistor? Well, consider that this place right here is touching a wire that's connected to ground. So in essence, this place right here is connected to ground. And if it's connected to ground, it must have 0 volts. So what about the middle? Well, along the resistor, something is happening where the pressure, the voltage, is falling from 5 volts at the left to 0 volts at the right. So if we measure the voltage right there in the dead center, take a moment and pause and think, what will the voltage be right there in the dead center of the resistor? I'll wait. You might have guessed 2.5 volts. And if you did, congratulations, that is correct. What about over like, let's say here? Well, there it's going to be like, I don't know, about 4 volts or something. Obviously, I'm kind of estimating here. And down here, maybe like, I don't know, 1 volt. And it's going to be a linear fall from 5 down to 0. So who cares? I'm going to show you we care. We're going to take advantage of this fact that the the voltage falls across the resistor. We're going to take advantage of that to build a device which acts as an input. The Arduino, after all, is a voltmeter. It can measure voltages. It can't do a whole lot else. It can provide voltages. That's what we've been doing so far. We've been providing 5 volts to an LED or not providing 5 volts. That is a blink, either providing or not. Goes on or off. Looks like my camera cut out. Sorry, 1 second. I'll be back momentarily in the corner, but I'll keep talking. So what we can do is use the Arduino as a voltmeter. So we can take this 5-volt connection, put it down to ground over there, and add a special little thing, which I'm going to draw as a little arrow with a leg coming out. This thing that I've drawn in that circle, that is a potentiometer. It is a resistor that has an extra little thing pointing at the middle of it. And that little thing is called the wiper. This middle leg is called the wiper. The middle leg there is movable. It is able to physically move and touch a different part of that internal resistor that's internal to the potentiometer. Everything in the circle is the potentiometer. And that is indeed the schematic symbol for that part. So how would we actually wire one of these up? Well, first of all, let me show you what a potentiometer looks like. A potentiometer in your kit might look like this. It's a little metal can. It says B10K on the front. It's got 3 legs on the bottom. This is the first component we've seen with 3 legs instead of 2. And this is a turnable little knob. Well, I've done a little bit of violence to this one, and I've peeled the can off of the back so that we can see the insides of it and understand how it works a little bit better. And here's the special feature of the potentiometer. I'm going to focus on it. I'm going to try to focus on it. Come on. The special feature of the potentiometer is it has these little things here which are able to touch that black background of this thing. The black background is the resistor, and I want you to see that this outside leg and this outside leg are both connected to the edges of the resistor. The middle is the wiper, and the middle are those little metal things, and look at that, they change where they touch it physically. As I turn the knob, they change where they touch it. And where does that middle leg go? It goes down to this middle leg. So this thing is connected to this thing, means this thing is connected to this, and which means you can move the place the middle leg is touching the resistor, which travels along the outside of this. So just to do a sort of a semi-schematic drawing of this part, which is not a true schematic drawing, you won't see it in an electrical plan anywhere, but it's kind of like, it's got 3 legs, it's kind of like a resistive path going along the outside, and then the middle here is the thing that's able to move. So do not draw this as a schematic, use this instead, but I hope this helps illustrate the point of how it works. So how will we actually wire this up to an Arduino? It's actually pretty straightforward. I draw my potentiometer. It's got 3 legs. Outside leg number 1 will be connected to power. Outside leg number 2 will be connected to ground. The middle leg, the wiper, we're going to connect it to an Arduino. Okay, well, first of all, where did the power and the ground come from? We better make that really clear. This is where the power came from, and the ground came from there. So this is actually, connected by a dotted line to that ground. This 5 volt is connected by a dotted line to that 5 volts. But now what do we do with this middle leg? So far what we've used is some pins over here on the right. Let's say like pin 5 to drive an LED. This is a thing that's going to produce a varying input voltage, which means we're going to do an analog input pin. Now you have choices of analog input pins. You have A0 on the top, down through A5 at the bottom, and you could choose any one you want. I will put this into pin A0. This then is the schematic for how to wire up potentiometer so that changing the position of the wiper, i.e. changing the voltage of the wiper, will be something that the Arduino is able to read. Next, we're actually going to do the breadboard work of wiring this up because it might be a little confusing at first, especially when you're new to it. And then we'll actually read the potentiometer in software.